Good day, matric students. Today I want us to have a drawing approach to this section called trigonometry, and it forms an integral part of paper 2 mathematics. And watching this video may be a refreshing choice for some of you who are in a palpable panic, precisely because you will be sitting for a matric exam, not in a long distance time. Look, students, trigonometry has a lot of marks. I will say 70% of your focus should be on this section and Euclidean in paper 2 mathematics. Let me tell you why. This is because look at question 5, which is your trig. And remember, and here we do not have general solution. Sometimes it's going to have 20 marks. This question 5 situation. In this case, they are giving you 17 marks. It's not the only part of trigonometry. This is some parts of it where you simplify, you prove, and you also evaluate without the use of a calculator. They normally give it 17 marks, 18 marks, or 20 marks. Now, you go to question 6. That is your trig functions. You go to question 7. That is your 3D. So it has a lot of marks if you are to pay close attention to that. And also analytical geometry and Euclidean, you use trig in some parts of questions there. So 70% of your attention should be on this focus where you master it properly. But however, I want us to solve the first question, 5.1. They are saying, without using a calculator, simplify the following expression to one trigonometric ratio. They are saying to 1. Take note of that, to 1. They are basically saying, do not leave your answer with a sine x, cos x. These are two trig ratio. It must be either sine x or a cos x, or even the tangent, because the tangent is also part of a trigonometric ratio. So you can leave your term with either sine or cos or tangent. It may be negative, those situations. So make sure that you adhere to the question. I'm now going to attempt the questions. The first one, we are given that it's the sine of 140 degrees multiplied by sine of 360 degrees minus x divided by the cos of the acute angle, which is 50 degrees, multiplied by the tangent of negative x. We want to simplify that. Let me copy it, and then we see how far we can go with that. 5.1. Let me just write here. We have a sine of 140 degrees multiplied by a sine of 360 degrees minus x. And now we've got a cos of 50 degrees. That is primarily your acute angle there, multiplied by the tangent of a negative x. I want you guys to say something. Let's take 140 degrees for an instance. Now, and let's visualize it. 140 degrees is primarily the obtuse angle, which behaves something like that. That is in the second quadrant. It's called obtuse. So if I'm to measure that angle from the positive x-axis, I'm going to have 140 degrees. Now, but if you are to look at it, you are 40 degrees away to the supplementary angles. So it means here it's 40 degrees. If here it's 180 degrees, that we know, from analytical geometry arguments. Now, we are going to say 180 minus 40 degrees is going to give us back that angle. So now, if we are to observe that, we are going to have it in this way, to say this is a sine of 180 degrees minus a 40 degrees there, multiplied by, if you look at this situation, it's a situation of the fourth quadrant where sine is negative. So I'm going to have a negative sine x there, multiplied by Now, if you are to look at 50 degrees, so 50 degrees, that is your acute angle in the first quadrant. So I'm going to have it in this way. I'm going to have my 50 here. If I'm to measure that acute from the positive x-axis, I'm going to get 50 degrees there. Remember that you have got your 90 degrees just right at that pole. So it means you are 40 degrees away if you are at 50 there as acute. So both of them are acute, these angles. This means that now I'm going to have a cos of 90 degrees minus this 40 degrees there. I'm just going to have that. Now I'm going to multiply by this situation. So this situation is basically called fundamental identities, where you have a negative tangent of x. You can take that angle out. It's called fundamental. And then this one, we call it the co-functions identity. But if you don't know it, it won't really affect you as long as you know how to work it out. So now you are going to say to yourself, if you look at this one, it's 1/8 minus, which is in the second quadrant, and that's where sine is positive. So I'm going to get a positive sine of that reference angle, which is 40 degrees, multiplied by a negative sine x there. If you look at this one, like I said, it's a co-function identity. That is in the first quadrant, where everything is positive. So I'm going to have a positive of the co-function of cos, which is sine. But now I'm going to take that angle of 40 degrees there. Now, I want you to observe something. Now I'm going to multiply by this one, which is a negative tangent of x. Mathematically, we can see that there is at least a literal sense now that that one and that one are going to undo each other, and the negative and the negative are also going to undo each other. So we are left with the sine of x divided by the tangent of x. So mathematically, this is equivalent to sine x divided by tangent. But tangent, to simplify it nicely, you can say that is a sine x divided by cos x. Now, you are going to apply something which you have learned from high school. I mean, from the lower grades, since you are in high school. Now, you're going to get a sine x. And then you now then multiply by the inverse of that, which is really your cos x divided by sine x. I hope this math is clear to some of you guys. So now this one and that one are going to cancel out, and as a result you're going to get a cos of x, which is primarily that one. I'm not mushrooming it from anywhere. So we have our answer as cos of x. So please, you must know how to simplify such problems. They are equally important to the questions you should be counting in the bedroom from now until the day you'll be writing. Now let's check the next question. Let's check the next question, which is 5.2. They are saying to us, prove the identity minus 2 sine square of x plus cos x plus 1 over 1 minus cos of 540 degrees minus x is equivalent to twice cos x minus 1. So let's copy it down and play with that. Now we're going to have a negative of 2 sine x squared, and then a plus a cos of x there, plus 1 divided by, you have your 1 minus cos of 540 degrees minus x there. We are saying this is equivalent to twice cos x minus 1. We can always verify that problem. So it's negative 2 sine x squared and that portion. Now, I don't want to waste time. I'm going to prove it. So because this is your left side and that is your right hand side, I advise my students to always prove the side that is complex than the other side. So you have two sides here, the left hand side and the right hand side. You are going to look at the complex side and prove from there. So in our case here, unless otherwise, the left side is complex than the right side. So I'm going to be proving from the left side. So I'm just going to copy it to show you that I'm now going to be proving from the left, and it must really give me what I have on the right. These are takeaways in the exam, but students are really gasping and gasping in the exam. I'll tell you why. Let's prove it. I'm going to say this is equals to, because it seems like everything must be left in terms of cos there, as a signal trig ratio there of cos x. But I see a square identity of sine squared x, which is equivalent to 1 minus cos squared of x. So this answers us to the scenario of saying that we're going to have a negative 2 multiplied by, I'm going to change this to be in terms of cos, and that becomes 1 minus a cos squared of x. We call this a square identity. Now, this is cos, and I can't really change that. So I'm going to write a plus cos of x. There's plus 1 there, which is this one. I don't want to mess up. So now I see that I have my 1 minus a cos. So you see that this 540 is it's misbehaving. I'm going to copy it here. This is 540 degrees. This is 540 degrees. So this 540 degrees, it has now completed the first revolution. It's probably in your first quadrant after the first revolution. By that, I mean you actually have it in this way that the complete revolution from that to that is going to give you 360 degrees. So now, if you are to get to 540, it's probably in your second quadrant. So you are going now to count again, and from there you're going to get, if you add 90 there, you might get something else, and then 540 is probably somewhere there. So, but the best way to do it is when you subtract 360 from 540. So I'm going to subtract 360 from that to get the actual angle that is equivalent to that one. So let me do that in my calculator. 540 minus 360, we get 180 degrees, which falls within the first completion of our first revolution. So now I'm also going to copy it, that result, and put it here, just there, and then I have minus x, such that I can deal with that. And then now I need to simplify my maths to say minus 2 times 1, that is a negative 2, and then this one times that, really it gives us a positive twice cos squared of x, and we still have our cos x plus 1 there. And then we have 1 minus. I want us to be very careful with our algebra here. This portion on its own, it's in the second quadrant, and cos is negative in there. So check the maths here. I'm going to write these brackets and say negative of cos of x there. Please make sure you are not intimidated by this answer here. It's basically that reduction from your early grades there, which is probably grade 11. Now, this is going to be equivalent to, I'm going to arrange it in order because in the numerator, I see that I have a beautiful quadratic equation. So this is going to be twice cos squared of x, and then a plus cos x, and the negative 1 plus 1 is primarily negative 1 divided by, you will see that you're going to get a 1 plus a cos x plus a cos x there, just like that. Now we are going to really factorize our numerator. Let's see what are we going to get if we try to factorize that. It's a beautiful quadratic equation. I'm not expecting a grade 12 learner to really battle with that. So we're going to have two brackets there to say that is twice cos x there, and then minus 1, and then we have a cos x there plus 1. I may really need to reduce this particular bracket there, divided by, I have a cos x a plus 1, which is this one. It's equivalent to cos x plus 1. 1 plus cos x is the same as cos x plus 1. So don't jungle them. Now, you will notice that these ones are the like term, so they undo each other, and we are left with twice cos x minus 1. Now, when you are here, you need to check what you are proving. So you are proving that you are going to arrive to a location of cos x minus 1, and that's where you have arrived, and that side was the right one. So you must write which is the right hand side, and then you are going to get full marks for doing that. If you have any question on how I solved this one, you are more than allowed to really comment on the comment section below, so that I can attend to your issues or your questions. Now, let us look at 5.3 just to save time as well. 5.3, we are done with this one. We're actually done. Now, we look at 5.3. They are giving you some stuff there. Let me do that. So 5.3. They are giving us that, let me check it carefully. It's sine 36 is equal to that stuff. Okay. So we have a sine of 36 degrees, which is really equals to the square root of 1 minus p squared. I hope you are familiar with this type of questions, but the mistake that students make or commit in the exam is to go to the questions without understanding this stuff. And I want you guys to say something. You see, they are just giving you that statement. There is no restrictions as to how you are going to play with that. Sometimes they will say P is bigger than 0, meaning positive. Or they will say cos x, maybe they can say tan x is less than 0. They will just do those things for you. So right now, there's no conditions. It means we are going to draw our diagram, which is always a right-angled triangle, in the first quadrant if we do not have any restrictions. Now, let's check. We are given a sine of 360 degrees, which is equal to this stuff. So this stuff is primarily the same as when it's divided by 1. Come to think about it, anything divided by 1 is basically itself. So now you are going to have your beautiful triangle in the first quadrant. In the first quadrant, just like this. I'm drawing it for you. Let me have my beautiful triangle. I just need to draw it properly. Actually, let me do this. Yes, now it's fine. So observe that this angle, you can measure it from the positive x-axis. That is 360 degrees. And that is your 90 degrees. Like I said, you always draw a right-angled triangle. So you may need to find out that angle using geometry reasoning to say the sum of angles of a triangle, they give you 180. So it's 180 minus 90 minus 36. It gives you 54. So that is 54 degrees. Now, the sine of 360, that is going to be the opposite side of it. And this is going to be the adjacent part of it. And that is going to be your HP there, the hypotenuse, HYP there. We call it the hypotenuse. I hope you know that. So the sine, it's opposite over hypotenuse. That means you are going to have the opposite of 1 minus a p squared, and then the hypotenuse is going to be really equals to 1. And you need to find the positive adjacent side by the use of Pythagoras theorem. So that is x squared plus y squared is equals to your r squared, the radius squared, which is the hypotenuse in this case. So your x is the adjacent side. You are looking for that. That is x squared plus your y. But your y is primarily 1 minus p squared. All squared is equals to 1 squared. So therefore, you are going to get x squared, and then that square root is going to undo with a square there. You're going to get a plus 1 minus p squared is equals to 1. Therefore, you get x squared is equals to p squared. So you want to solve for the x, or rather the adjacent side. That becomes x is equal. You normally say plus or minus if it's quadratic, but this time around, I'm going to write positive p on the basis that we are in the first quadrant. And on the first quadrant, everything is negative. So you have the value of p for the adjacent side. Make sure that you do this before you go to questions, because if you don't do this, questions are going to pulverize you. They are going to hang you like a light bulb. So this is a must do in this type of questions. Once you are unable to do that, you must then forget about it, because the question itself is going to unseat you throughout. Let's check 5.3.1. What are they saying? They are giving you 3 marks after all, and that is the tangent of 36 degrees. So I'm gonna write that to say 5.3.1. We want to find a tangent of 360 degrees. What is a tangent? This is the same as saying the opposite over the adjacent. But we've just solved the adjacent, and the opposite length of that was given as a square root of 1 minus p all squared divided by your adjacent, and you found that to be your p. And you get 3 marks for that. You know, you need to really get that marks. And then where the marks coming from here is basically 2 marks for that, for the answer. And then you also being able to find the value of p by means of your Pythagoras theorem there. So it's a very important section, trigonometry, and advise students to really practice that stuff. Now, 5.3.2, which is our last question of the day, or rather of this series. Let's see what are they saying to us. They are saying cos of 108 degrees. Okay, so you want to find the cos of 108 degrees, not 180, but 108 degrees. Look, students, my advice to you is that think of this particular angle. There are many ways to express it. You know, there are myriad of ways to express that. One can say 108 is the same as 72 degrees plus 36, or you can really say that 108 is basically in your second quadrant. So you can apply or reapply the reduction, guys, to say this is equals to the cos of 180 degrees minus, because that is in the second quadrant. So we can say minus 72 degrees there. Now, because that is your second quadrant where cos is negative in that space, so we're going to have a negative of cos of 72 degrees. Come to think about it, this angle here has a relationship with what you are given. Let me check what's that. What we are given as 36 degrees there. So there is a mutual relationship between this angle of 72 and the angle of 36 degrees. And the relationship is that 72 is the same as 2 twice 36. And that then ushers you to the word of your double angle identity. So I'm going to say to myself now that this is the same as a negative cos of twice multiplied by 36 degrees. You know, you close that. It is the same as 72 degrees. We are doing this on the premise of the fact that there is a serious relationship between this angle and what we were given as 36. So what's left now is to really apply the double angle of cosine. So there are three ways of expressing the double angle of cos. So I'm going to choose the one which is easier for me at this particular point. And I'm going to choose, because I was given that, where is it? I was given that sine of that is the same as what do you call that, as root of y minus p. So what you can do is you can say this is equals to minus, you open the brackets, and then this situation here is, there are three ways of doing that, so you can choose whichever way. I'm thinking of cos. So this is twice cos squared of x minus 1. Remember, you could have said it's 1 minus twice sine squared of angle. But that angle right now is 36. So I'm going to say this is 36 degrees. Why? Because I know the value of that. And that is really going to give me, let's check. We are going to get a negative twice cos squared of 36, which is the same as cos 36 degrees all squared. And then this time is that it's a positive scenario, and that is going to result in negative 2 times cos 36. So you look at your diagram, that is your adjacent over hypotenuse. So that is going to be P. That is going to be P over hypotenuse, which is 1 there. But don't forget to square your stuff. And this is plus 1. And as a result, you are going to get a negative 2 P squared plus 1 if you are to simplify that properly. Now then, thank you very much for watching. Like I said, if there's any question that you guys feel like I jangled or there was a quagmire in between them, you are more than allowed to comment in the section below. I'll go through your comments, and please guys, don't forget to subscribe to the channel